Hey guys, today I'm going to be teaching you about law of sines, which is from Unit 6.5. So, law of sines is a formula that's used to solve triangles. You can use it to calculate angles and sides on a triangle, specifically a triangle that's not a right triangle. So that's when this will become useful when you're dealing with triangles that aren't right triangles. So here is the big formula. This is the law of sines in question. Basically, you just have all of these equal to each other. It'll make more sense when you can see the triangles, but yeah, keep this in mind, write it down, put it in your notes. That's what you'll be using this whole time. So here's our first example. This is a triangle that we've been given an angle, and a side, like I said up here, crazy. So we're looking for angle B, side A, and side B. So to get started, we're going to figure out angle B. So how we're going to do this, we're going to add together angle A, angle C, and subtract it from 180 because all of the angles within a triangle will equal 180. So, like I said, add them together, subtract from 180, you get angle B is 135. So after you have that, we're going to go ahead and try to figure out side A. So this is where law of sines becomes helpful. So we're given angle C and side C, so we're going to use that and make it equal to A on both. So sine C over side C, sine A over side A. So plug in the numbers we have. We got angle, angle, side. So angle, angle, side, looking for a side. Cool. Now that this is plugged in, we're going to go ahead and cross multiply. Yep. When you cross multiply, I know this is a scary stream of numbers, but basically all I'm saying is you got sine 25 times A, boom, and then 80.4 times sine 20. Nice. So our next step is to get A by itself, since that's what we're looking for. So we're going to divide sine 25 on both sides. A by itself, divide sine 25 from this. Plug that. So basically plug this big bunch of numbers in your calculator. You'll get side A is 65.07. Cool. So we got angle B, side A. Let's go ahead and do side B. I'm going to repeat that same process again. Boom. C, we're going to see again because I trust those numbers. Plug it in, cross multiply, boom, then cross multiply. Let's get B by itself, divide sine 25 on both sides. Nice. Plug all this into your calculator, and you get B equals 134.52. So, little recap, we looked for angle B, which is 135, side A, and side B. This was an angle, angle, side triangle. So that's what we've been given. Cool. Law of sines. In this example, we just did with cross multiplying, and we were trying to find the side lengths. We didn't use law of sines for angles this time. We did the little addition. But what if you wanted to use law of sines to find the angles? Say you haven't been given a second angle to subtract from 180 by adding these together. No. You got to use law of sines. So we're looking for angle A, angle C, and side C. So we're going to go ahead and start by doing angle A. So I'm going to set it up equal to B because we're given angle B and side B. Cool. We're going to plug in the numbers we know. So we got angle, side, no angle because we're looking for that angle. We got another side. So we're going to do a little cross multiply. And then it's going to look like this. Cool. Let's go ahead and divide by that again. This is all stuff we've done before. Nice. So it's been divided. A is by itself. No, it's not. It has a little friend. Got the sign. You need to get rid of the sign. So to do that, you're going to first type that in your calculator, get it by itself, and then to get rid of the sign, multiply by the sign inverse on both sides. So this times this, got to cancel out, it'll just become A. So you do 1/2 times the sign inverse, and that'll give you the angle, which is 30 degrees. Yes, super cool. But one thing you do have to keep in mind, since you weren't given angle C, you kind of have two questions because you don't know what either of these angles are because of the information we're given. Oh Lord, I went too far. So anyways, because of the angles that we're given, there's some more possibilities for the angles. We got to double check to see if anything else will fit. So to do that, you're going to take the angle you got with the law of sines and subtract it from 180. And okay, we'll do it for this one. You get 150. You're going to go ahead and add that with the angle you do know, which is angle B in this case. All right, so because this is 195, that means angle A cannot be 150. So, boo. So this one we only have to worry about 30, but this is a process you'll need to remember. We'll go over it in the next example. Here's my little notes. You can write them down if they're useful. All right. So let's go ahead. We got angle A. Well, let's go ahead and get angle C. Now we get to do the nice little addition again. We're going to add 45 and 30, subtract it from 180, get angle C is 105. Nice. So, got both our angles. We got all the angles of the triangle. Super nice. Let's go ahead and find our last side, C. So, for this one, because we have 7 and 30, I'm going to use that because I feel like it's a little easier than looking at 7 root 2. You'll get the same thing regardless, but this is just easier on the brain. So, make those equal to each other. Plug in what you know. Cross multiply. Boom. It's just the same as the first example. No sine inverse, you're looking for a side. So, nice and easy. Boom. Enter that in your calculator. And here we go. Side C, 13.52. So, here's what we went over in this triangle. We got the angles and the side. We used it to find the angles. That was the big thing of this example, multiplying by that sine inverse. That's what you need to know to find angles. But when you find sides, you just cross multiply and divide to get them by yourself, dual algebra. Cool. So, if you remember, I mentioned how you just subtract your first angle that you find with the law of sines from 180 to see if there's other possibilities. Let's go over an example that will have other possibilities. So, here's another side-side angle triangle. So we're looking for angle B, angle C, and side C. So we're going to go ahead and look for angle B first. We're going to use law of sines. So we're going to plug in. We got A for the side and the angle. We'll use that and set B equal to that. Plug in what you know, like we said. Good triangle. Boom, boom, boom. And cross multiply. Alright, let's go ahead and divide to get sine B on its own. And then we do that. And so normally when I do this, I would multiply by the sine inverse of like this, but this is just to make the presentation look nicer. Sine inverse. Boom. Cool. Angle B, right? Wrong. Well, half wrong. So, let's see. We don't know angle C, like I said before, so this has multiple possibilities. Cool. So, let's subtract 65.82 from 180, and then we get this. Let's add that with the other angle we know. Boom. Okay. Hey, that is less than 180. So that means that since this is less than 180, 65.82 isn't the only possible answer. These are the both possibilities for angle B to make this triangle true. Just because we don't have enough information to just have one, we have to do both possibilities. So, let's do that. Basically all you're going to do, really tedious, but you're just going to repeat your normal law of sine solving for both of these possibilities, just repetition. So, here's option 1. Using 65.82 as angle B, we're going to find angle C. Get to add them together, subtract from 180, get 71.08. Super nice. We like this part. Let's go ahead. We're going to use real law of sines now. Looking for side C. This one's nice, just the normal. Set it up. We're going to use A, and then C. So, looking at what we know. Angle, side. Looking for C. Cross multiply. Cool. Cross multiplied. We're going to go ahead, divide this from this, so we can get C by itself. C's by itself. Do that. Plug all this into your calculator. And then we have C is 257.8. Cool. You just figured out the first option. No sine inverses for this part. You're just doing normal law of sines. Just find the sides. We only have to use the sine inverse for B on this example. So let's go ahead. We got our option 1, 65.82, 71.08, and side C, 257.8. Let's go ahead and do option 2. Same process, just with other numbers. So in this case, here's our other angle B, and we're going to set it up the same for angle C. Add together, subtract from 180, get angle C. Super cool. Then we're going to do find side C again, but with our new angle numbers. Alright, so let's do sine A, sine C, plug in what you know from the data. Cool. Cross multiply. Cool. Then divide by sine 43.1 on both sides. C is going to equal this bunch of numbers. Enter that in your calculator, and you get 105.25. So, here's what we got. We got both. Oh, we're still on option 2. We can't that bad. So we got angle B, angle C, and side C. So basically all example 3 did is we just had to solve for 2 possibilities for this triangle. So what do? We use law of sines to figure out angle B, we had to use a sine inverse to figure that out. Then we also used the law of sines to find the side lengths. We used to define C in both parts. But the main thing we went over in this example that was different was we checked for other angles, since we have two questionable angles, so there was more space for possible triangles. Cool. So now we know law of sines. Why do we need to know this? Why is it useful in the real world? Well, there are some jobs you can use it for civil engineering. You can use it to build beams. What length should the beam be on your bridge? What angle should it be installed so my bridge doesn't fall? You can use it to find the height of buildings. I like the example with Tower of Pisa because it's not straight up and down, so it's not a right triangle. So law of sines, you'd have to use it. You can also use it to do angles of a ladder. Maybe you don't have a straight surface. Maybe you put a ladder on a tree and the tree's bent. Don't put ladders on trees. For AET people, it can also be useful for if you're making like a triangle room. You want to have a weird recording room and you need to find out the sides of the walls and the angles. It can also help you, once you know that, you can figure out how the reflections are going to go about and stuff, all that kind of cool stuff. So yeah, once again, here is the law of sines. Memorize it, write it down, put it on your note sheets. Cool. Hope that this video was useful, and have a great day.